Okay, I will share the screen. Sir, I hope my presentation is visible.
Yes, yes, yes. Visible, sir.
Okay, okay, okay. So good afternoon all. So our next session is on the intrusion detection and prevention system. Okay, a case study of SNORT IDS. So I will be talking about the SNORT IDS. Okay, what is the importance of IDS? Okay, what are the things which are prior to IDS? And my summer intern, the Mr. Priyadarshan, he will be giving the demo on the SNOT IDS. Okay, so he's a summer intern working with me. So he will present different actions of the options available with the SNOT IDS, just like alert, packet drop, and the redirect. Okay. So this is the outline, okay, of the today's talk. So again, I will begin with the MITRE attack framework. I will talk why it is very required. Okay. So just see, these are the common attack tactics used by the typical attack scenario. It starts with reconnaissance, resource development, initial access, execution, persistence, like that, up to the impact. So some of these activities happens at the network level. Some of these activities happens at the host level. So when we go for the software solution, security-based solutions, some of this we need to have some solutions to be deployed at the network level, and some of the security solution need to be deployed at the host level. Okay, or there may be a security solution which works at the both host and level and the network level also. So which looks for the malicious traffic and which looks for the certain things which are happening within a system. Okay, malicious things. Okay, so uh, so each of these activities, some activities happens at the network level, some activities happens at the host level. So accordingly, the security solutions will be devised and put into the network. Okay. So let me start with this first, reconnaissance. Okay. So just see. So as the in this session we are going to discuss about the intrusion detection and prevention system (IDPS). So first we need to understand some typical attack scenarios. Okay, so I will just discuss some typical attack scenarios. Okay, and then we'll go for the SNOT. Okay, we'll discuss the ideas. So you might have heard about the Nmap. Okay, network mapper, which is a very common utility or the tool used for the port scanning. So before, as I said, in the reconnaissance phase, attacker what he does, he or she try to gather as much as information about the victim organization or the victim or the victim machine. So when we say about the victim machine, it may be a simple machine, workstation, or the server. The attacker want to know that what are the ports open onto that particular system. Because based on the ports, the well-known ports, they will figure out what are the services running onto that system, and if it is a HTTPS service is running, they will assume that it's a web server. If it is a MySQL service is running onto this particular computer or the machine, they can understand that it's a sort of database server or something like that. So they will figure out. So once these services come to know, they came to know about the open ports, they come to know about what are the services running onto this ports. They will what they will do, they will identify the well-known vulnerabilities on those services, and if there is a well-known vulnerability is there, then they can use the exploits from the exploit DB or some well-known exploits which are available, and they will try to infect or hack the machine, take the control of the machine. So normally we do the port scanning as a part of penetration testing, but basically port scanning itself comes as an attack. It comes under the category of attack. So if somebody does the port scanning using a network mapper, Nmap or Zenmap, or by using any other tool, this activity itself comes under the attack. Okay, so it is a part of attack and it is considered as attack. So normally it is advisable not to do port scanning of government website or any institution websites. Okay, so better not to do the port scanning because it is considered as a precursor for the attack. Okay, and these are some of the options available what you can do with the so it's an open source tool for network exploitation and security auditing, and you can use the raw packets to determine what hosts are available on the network, what ports are open on each host, what services they are running, what is the OS their version, and something like that, whether the packets are filtered or not filtered, what is the location of firewall, everything can be identified, and there are some nmap options are there. Okay, so The point is the port scanning itself considered as a attack attempt. Then some common attack I'm talking about network-based attack, the SYN flood attack, the TCP three-way handshake. So there is a sort of flaw in the TCP three-way handshake, and that flaw or that thing can be misused or abused by the attacker to open lot of to send a lot of SYN packets to the server, and the server will reserve the resources for that those SYN packets. It will send the acknowledgement and expect the final acknowledgement packet for the send SYN, but the attacker never does that. So kind of flooding attack may happen. So if you wanted to create the signature for port scanning in the intrusion detection system or the flooding attack, we can create those signatures. That's why I'm discussing them. Okay. So you already know about this. Okay, this is a well-known attack. Then some sort of DOS attack, where maybe you can perform the volume-based UDP flood, ICMP flood attack. Some amplification attacks are there. Protocol-based attacks are there. Different types of flooding attacks are there. Okay, using the different protocols, you can do the flooding attack. Okay, and you can exhaust the resources onto the server. So the server resources are not available for the legitimate users. It's a sort of denial of service. So these attacks are very common in the wild, and you can use the IDS, basically SNOT, to create a signature for these attacks. So some of the attacks we are going to demonstrate. Okay, simple attacks, not complicated or sophisticated attack, and we will tell you how to create the signature for them and how the IDS will deal with these packets. Okay, so whether it will give the alert, or whether it will drop the packet, or whether it will redirect it, those packets, to some other machine. We'll study those things. Then the distributed denial of service attack, if there are multiple bots are involved. So multiple machines will be compromised, and those machines will be compromised using the bots. So those bots will act as zombies, and for all these zombies there will be, or for all these bots there will be a bot master. So here attacker is a bot master, and he's controlling. He deployed a lot of bots, and those bots are infecting the machines. Each of those machines will act as a zombies, and these bots will create further some more bots, and these machines will also act as a zombies, and they will all together will attack the server. Okay, so this is the attack is not happening from one place or from one machine. It is distributed in nature. That's why it is called distributed denial of service attack. So this is also very common in in wild. Okay, it happens. Okay, so again some more attacks are I have listed here. So what we will do, okay, with this knowledge, what we will do, we will see the IDS part, how the IDS, how these signatures can be created in IDS, SNOT IDS, and how we can generate the alert or drop the packets. Okay, so again, the related thing I'm discussing is a packet sniffing here. So because IDS, one of the mode of IDS is IDS acts as a packet sniffer. Okay, so first it sniffs the packet out of the network. So basically, when we talk about the SNOT IDS, it is a network-based IDS intrusion detection system. So it sniffs the packets out of the switch. Okay, using a spanning port. So IDS acts as a packet sniffer. Okay, so you know what is the purpose of packet sniffing? So it's a process of capturing and analyzing the data packets. So there are some legitimate use cases are also there. There are some malicious use cases of packet sniffing are also there. So when we talk about attacker point of view, what attacker will do? Attacker may stage a passive attack onto your network. He or she may sniff the he will eavesdrop on the your network packets. He will snip the packet, and they will study those packets for login credential and emails. Okay, some content they will extract, and that data they will use for staging the further attacks. Okay, so there are malicious use cases of packet sniffing are there, whereas there are legitimate use cases are also there. So you can sniff, network administrator can use the packet, or he or she can sniff the packet using Wireshark to analyze, to do the network diagnostic, to do the performance analysis, whether bandwidth is the we are getting the desired level of bandwidth performance or not. They can troubleshoot the network connectivity issues. They can detect the intrusion, or they can find out the suspicious activities. So many legitimate use cases are there. One of the legitimate use cases of packet sniffing is intrusion detection. So that's why I said SNOT IDS, one of the operating mode is a sniffing mode. First, it sniffs the packet, then it does the packet analysis, in-depth packet analysis, maybe the deep packet inspection, and based on that, it takes the decision whether to drop the packet, to alert or drop the packet or redirect. Okay. So there are some common packet sniffing tools are there. Wireshark, TCP dump, ettercap is there. Okay. So So you might have heard about the Wireshark. Okay. So in the very basic mode, SNORT IDS works just like a Wireshark. Okay. Very basic mode. Only the visualization is not there. A Wireshark is having pretty good visualization. Okay. You can visualize the packets in a human readable format. But IDS, SNOT IDS don't have that much visualization capability. But as a in its basics, it works like a packet sniffer. Okay. So one more thing I would like to before discussing the ideas, I would just like to talk about the firewall. Okay, so firewall is another device which also works on the network traffic. It is a network level device. It is a host level device also because we are having Windows firewalls also. So if you wanted to put some restriction onto the network traffic, we can have the firewall. We can have the access control policies configured inside the firewall. So you can see in the diagram. So there are two. One is external firewall, one is internal firewall. Demilitarized zone is created, and there are access control policies are configured onto the firewall, and based on the policies, blacklisting or whitelisting of IP addresses, based on ports, you can restrict the traffic. Means these firewalls we can stop, can helpful in stopping the unauthorized, network traffic to the which is coming to the internal network. So, okay, this is also, it is not an IDS, it is not an intrusion detection system. What it does, it simply blocks the traffic. Simply what it will do, if it's a legitimate traffic, then it will, if this traffic is as per the access control policies, it will allow the traffic. If it is traffic is not as per the access control policies, it will simply deny the traffic, it will block the traffic. So firewall is like that, okay? So again, there are different types of firewalls are there: packet filtering firewalls, stateful infection firewall, inspection firewall, proxy firewall. There is a NAT is also work as a firewall, next generation firewall. Okay, so it's there is a lot of developments are happening in the firewall. So here you can see the next generation firewall. It does the intrusion prevention also. Okay, but it doesn't go for the deep it goes for the deep packet inspection also. So sometimes you may ask a question, what is the difference between firewall and what is the difference between IDS? So when you consider the next generation firewall, it not only does the packet filtering, it does the intrusion prevention and deep packet inspection also. So nowadays the boundary between this firewall, next generation firewall and intrusion detection system is very thin. So sometimes companies can simply deploy the next generation firewall to fulfill their purpose. Sometimes the companies can have the separate firewall and they can have the separate intrusion detection system for the deep packet inspection and the intrusion prevention. Okay. So it depends on company to company what they prefer. Okay, because there are deployment costs also there. You have to find out the vantage point for the deployment. And this firewall and the ideas we should work in synergy, or this there should must be some sort of harmony among these two devices to get the proper level of security strength. So there is another one is called as the UTM, Unified Threat Modeling UTM. Instead of deploying the firewall IDS separately, you can have the single box. Within that, you can have the everything together, and you can deploy at the network level, and it does the job. Okay. So when we talk about the firewall, again, there are some packet filters are there, the basic, okay. So it works at the network level, okay. It is aware about the traffic. So IP, port, and protocol level inspection you can do. But connection tracking and threat detection, it doesn't do, okay. Some use cases are there. It will be used for the low resource environment, okay. And there is testful infection firewall. It works from layer 3 to layer 4. When I say layer 3 to layer 4, I'm talking about network layer and the transport layer, okay. And it is a traffic aware, so TCP handshake, okay. So connection state, it is aware about the connection state, and it track the connection also. Threat detection is limited here. When you talk about the next generation firewall, from the layer 3 to level 7, okay. So from network layer to up to the application layer, you can have everything, and you can do the deep packet inspection. You can monitor the content if it is not encrypted, okay. And it will have the integrated intrusion prevention system and threat intelligence system also, okay. So like that. So there are firewall is a category, next generation firewall. Sometimes it acts as a intrusion detection and prevention system also, but that is not our objective. We are going to study the intrusion detection system separately, okay. So what is the IDS basically? It is a host or network based system. What it does, it monitors the traffic, or it monitors the system activities. As I said, in a MITRE attack framework, when we see some of the attack stages which happens at the network level, some of the attack stages happens at the system level. So accordingly, we should have the intrusion detection system both at the network level and at the system level also. So system level IDS, what it will do, it will be more interested in the traffic part, whereas the host level IDS will be more interested in the system level activities. Okay, so it will monitor the file, it will monitor the processes, okay, all those things. It will monitor the services also. So altogether, the IDS, whether host or network based, they monitor the traffic, they monitor the system activities for the sign of malicious behavior. Okay, and what happens basically? So it is specialized in detecting the attack which bypasses traditional security controls which are put in place in the network, just like a firewall and antivirus solution. So we can say that firewalls are there, antivirus solutions are there, but sometimes what happens, the attacker will stage the attack in such a way that they may bypass the firewall, or they may fool the firewall, or they may bypass the antivirus software. Okay, so that will happen. That is called as defense evasion. That is called as defensive solution evasion. So we should have the extra layer of solution as a intrusion detection system. Okay, so it should alert. It also alerts operators, security administrator about the suspicious activities which are happening at the network level and which are happening within the system. Or there may be, if there is a violation of security policy, then it will alert about all these violations. It provides the forensic data to support incident response and root cause analysis. So if there is a cyber incident happen, then the forensic investigation start. So this IDS basically logs everything. Okay, so it provides data which support the forensic activity. So okay, that means it supports in reactive forensic. Parallelly, it supports in proactive forensic also. So what it does basically, based on the rules configured, it will drop the packets. The drop packets will be stored into the database, MySQL database. And actually, before attack succeed, you are dropping the packets, and then you do the analysis of those packets, and you will identify why such things are happening in my network. What is the thing inside my network? What is the resource inside my network which attracts the attacker? So some sort of proactive forensic you can do, and you can generate some sort of threat intelligence, and you can share with the peers. Okay, so there are examples of snorts are there. There are some open source snorts are there. There are some licensed snorts are available from the companies, paid versions. So open source, among open source snort is very famous. Okay, basically it is maintained by Cisco. There is a Suricata is also, it is also open source snort. There is a Bro IDS is there. OS6 Wazoo is there. Dragos. There are so many IDS are available. Some are open source, some are licensed versions are available, or paid versions are available. So when you talk about the history of IDS, so in 1970s, the log analysis will be done by the operators or security administrator purely manually. It is very hectic process to analyze the tons of logs. Okay, it's very difficult. Okay, then a formal intrusion detection system is proposed by Denning in 1980s. Okay, it's some sort of theoretical paper which talks about the ideas, false positive, false negative, true positive, true negative, all those things. It talks about that. And officially, the snort was introduced in 1990s. Very basic snort version, tripwire and commercial ideas. They started coming in 1990s. Again, now these ideas are evolving over the time. So this intrusion detection system become an intrusion prevention system. Okay, then Bro IDS is introduced, some hybrid models, because these IDS works on signatures. Some of the IDS works on anomaly based detection. So nowadays, in 2000, these IDS are working on hybrid, both signature based and anomaly based. Then, with the proliferation of AI and ML algorithms, now people are making use of these AI ML algorithms heavily using in intrusion detection and prevention system. And as the attacks are keep on happening on industrial control systems also, some ICS specific intrusions IDS were also introduced. So for the ICT network, IDS are very bulky, very heavyweight, whereas for industrial control systems, so these IDS are intrusion detection systems are very lightweight. Then this cloud, okay, as a lot of data people are outsourcing onto the cloud, and the IT and OT integration is happening. Again, accordingly, these ideas are getting evolved over the time. Okay, so there are cloud-based ideas are there. There are OT-related ideas are there. Okay, and now the people are making use of generative AI, because the attackers also keep on using the generative AI to create the malware. Okay, so they are taking generating the malware samples based on the generative AI. Okay, so people started using, the security researchers started using the ideas which take help of generative AI to create the malware signatures also. Okay, so this is the short history of IDS. Okay, and when we go to the typical classification IDS, there are we can classify in the first classification goes based on the location of the deployment where we are going to deploy. So if you are going to deploy the IDS on a particular host, if it is monitor the host activities, then it is called as host based IDS. If you are going to deploy it onto the network, then it is intrusion based network based IDS. Based on the detection method, if you are employing the signatures of the malware which are already happened or the attack which are already happened, if you are using those signatures to detect the attack, then that is a signature based IDS. But these signature based IDS may not work for uh, the new type of cyber attack. Okay, so then there will be anomaly based IDS. So anomaly based IDS can be used to deal with the kind of I can say flooding attacks. Okay, so based on this is normal behavior of my network, but suddenly there is a ingoing or outgoing traffic is very high. Then we can use some anomaly based detection algorithms to detect that. Okay, so anomaly based detection algorithm is also having some advantage over the signature based algorithms. But now people started using both signature based and anomaly based. Anomaly based algorithms are good at detecting the maybe the new type of attacks. So researchers started employing both signature based and anomaly based IDS. Okay. Now the next one is a classification based on the response capability. So how the IDS will respond to the attack scenario. So there will be a passive IDS. It will just alert. Okay, what it will do? It will scan. It will look for a particular attack based on the system activities or maybe the based on the network traffic, and it will simply alert the user, but it won't take any action. Okay, it won't do any concrete action against the packets or against the malware. There are another category of IDS called as active IDS. What they do basically, it's a called prevention system. So passive IDS is a detection system. It will simply detect the attack. It will alert the security administrator, but it won't do any action. Okay, against the attack. So that's why there is active IDS, also called as a intrusion prevention system. What it will do, it will not only look for the attack, network-based attack or system-based attack, it will have power to decide what to do with the attack, whether to drop the packet, malicious packets, or whether to stop a particular or quarantine or ransom or malware activity or kill the particular malicious process. So some extra privileges are delegated to this IPS, intrusion prevention system. So in that way, we can classify IDS based on their location of deployment, based on their detection method, and the response capability. So as this talk is about the IDS, so we are focusing on the SNORT IDS. So SNORT is created, developed around 1990s, and later on it is taken care by, Cisco is managing the SNORT IDS. So when you look at the SNORT IDS, so what happens basically is we assume that intruder is doing the attack from the outside. So the threat actor is outside to our network. He tries to attack the host present in the network. So when the traffic comes, that traffic goes to the SNOT sensor. There are SNOT nodes or SNOT sensor nodes are deployed throughout the network. Maybe one node, SNOT node, or maybe the multiple SNOT nodes are deployed. So the SNOT, investigates the traffic, and okay, so it stores that data into the MySQL database. Now, as it stores all that data, all the incoming data or the packet related data into the MySQL database, so the security administrator can use that data and can visualize the thing. So basically, security operator is looking at the intrusion data collected by the SNOT through the web browser. So like that, you can do that. So okay, so SNOT basically analyzes the packets. It checks against the well-known attacks, and if there is an attack is there, then accordingly it will alert or it will drop the packets, and all those things will be visualized by the security operator. There are some SNOT features are there. When you talk about SNOT features, it does real-time packet sniffing, as I said. Basically, it is one of the mode of SNOT is a packet sniffing mode. It sniffs the packet out of network and it logs them, it stores them. It does the protocol analysis for the multiple, whatever the protocol, HTTP, HTTPS, TCP, UDP, whatever, it does the protocol level analysis. Okay. It does the content searching and matching. If our traffic is a plain text, it does some sort of content searching and matching. If the attack traffic is encrypted, then the content searching and matching will not work. It detects various types of attacks, buffer overflow attacks, stealth port scans. As I said, the port scan can be considered as an attack attempt. So it detects that and some other things. And one of the good feature about the SNOT is that flexible rule-based language. The language which is used to craft the rules or design the rules is very flexible and it is very easy to understand. So anyway, we are going to see that. And talking about the SNOT operating modes, SNOT works in a sniffing mode. It reads and displays the packets. It works in a packet logger mode also. It logs the packets through the disk. It stores the disk for further investigation, future investigation, or for the forensic analysis. And what it does, it works in network intrusion detection mode. Means it analyzes the network traffic against the rules set, and accordingly it will take the action. If we are saying that drop the packets, it will drop the packet. If you are saying that if this particular packet match with this rule, then redirect it, then it will redirect, something like that. So accordingly it will act. So snort, these are the different snort operating modes. Now, talking about the components of SNOT, what the components SNOT ID is having, it is having the packet decoder. Okay, if you look at this diagram, so it is having the packet decoder. It decodes the packet. Okay, so because the packets are considered, packets are the binary data basically. Okay, so when the packet goes through the communication medium, if it is a fiber optic cable, those will be light pulses. If it is a simple cable, coaxial cable or twisted pair cable, those will be the voltage pulses, something like that. Those will be converted back to the binary stream, and then it will try to decode the packet, because every protocol packet is having a particular packet structure. TCP having the packet structure, UDP having the packet structure, like that. So it decodes the packet, okay, and then it processes the packet. After pre-processing, means it looks okay, it will pre-process some information, it will extract out of it. That extracted information will be given to the detection engine. And if we are saying that the particular packet is a part of attack, then drop that packet. It will drop the packet. It will drop the packet means it will not forward that packet further to the destination. It will simply drop it, but it will store that packet for the future, future investigation, further investigation. Parallelly, after detecting, it will log the packet and it will alert the security administrator. Okay, it will alert, and some more thing it can do. Okay, it can log the packet, it can store it. Okay, and it will alert the security operator. So these are the some of the components of the SNOT. Uh, okay, so there may be some these components are keep on changing based on the version of the SNOTs. Okay, they are keep on improvising these components. Coming to the SNOT, where we can keep these ideas. So assume this is the outside network connection to the internet. First, we are having the first layer of security defense as a defense in depth. We are having a firewall here. So firewall is a simple packet filter device. Assume it's a packet filter device. What it does, it looks for the unauthorized traffic. It looks for the, so there may be access control policies set up in a firewall based on the whitelisting or blacklisting of the IP addresses or the port numbers. It will allow or deny the traffic. Then the traffic which is allowed, it comes to the switch. Now the traffic here to the switch, we are having internal network. We are having some servers. Servers are some workstations or the PCs. Now we are having the IDS attached here. So these all the traffic before pushing that traffic to the these internal machines, the traffic should go to the IDS. So how it will do? So we'll having the switch, and in switch we'll have a spanning port. We'll configure the spanning port. Means what the spanning port does, so all the traffic destined for the remaining switch ports, that traffic will be go to the spanning port and it will go to the intrusion detection system. And this IDS, this machine is a powerful machine. It analyzes all the incoming traffic in real time, and it checks each and every packet for the attack attempt. And if the packet is okay, those packet will be forwarded to the destinations. If the something wrong with the packets are violating the security policy or not as per the access control rules, then those packets will be either blocked or can be redirected to another machine somewhere. Okay, so depends on the configuration of the IDS. So this is the way the IDS is connected to the spanning port in a typical infrastructure. Okay, then what is the location of IDS where you can put the IDS? So basically the IDS you should not keep at the very front. Okay, you should not expose the IDS to the internet. Okay, it should not be internet facing. First, what you do some sort of packet filtering, okay, at the firewall level or at the gateway router level. You do that, and then After that, give that traffic to the IDS. So IDS will look into the packet in depth, maybe the deep packet inspection it will do, and accordingly then it will do. So but nowadays what is happening, people are started using the UTM, unified threat modeling, or something like that, and in that box everything will be there, firewall will be there, IDS will be there. So from outside you can see only one thing, but inside there are multiple things are there. Okay. Now, so now what I will do, okay, so the next few slides are a bit technical. So I will ask my student, Mr. Priyadarshan. He's a summer intern. He's working with me on the SNORT ideas. Okay, so I will ask him to take you from here. He will explain how to install this SNORT on Windows, how to install it on the Linux, and then he will explain what are the different actions performed using the SNORT. Okay, so now I'm giving control to the Mr. Priyadarshan, and I will ask him to continue from here. Okay, so I'm stopping, stop sharing my slide, and I request the Priyadarshan to share the slide with you and explain the rest of the slides. Okay, so Satyaranjan sir, are you there? Can you share? Satyaranjan sir, is there someone from KIIT?
Yes, sir. Yes, sir. I am here. Okay, but
So my
yes, I am
yeah.
co-host. Okay, that's why I am
Okay, okay.
calling Satya sir to make Mr. Sudarshan as a co-host so that he can
Yes,
share the screen.
yes, yes.
Okay, just let.
Priyadarshan.
Yes,
His
yes,
name is, yes.
yes.
Yes, yes. He shared the screen. Now from here
Yeah.
onward, he will explain. Okay.
Yes, yes. Thank you.
Okay. Okay.
Good afternoon, folks. I'm audible.
You are audible. Please carry on.
Yes. Yeah, I'm Priyadarshan Vadivel, summer internship at NIT Trichy under the guidance of Dr. Gamchem Bopshe. So today I'm going to do a live practical of a SNOT intrusion detection system. Before getting into the topic, we just see an outline of it. So first we are going to see an installation, SNOT installation on Windows, SNOT installation on Linux, followed by the custom rules and what are the modules are there in SNOT, and we directly jump into the demo session. Now installing SNOT on Windows, it's simple. It's simple like we are installing the network mapping or Wireshark in our system. So first we want to download the binary file from this SNOT website. So after we want to install it. So in SNOT, it's basically built for a Linux system. It's not basically built for a Windows. So we want to configure the config file, especially the file path. So all stuffs built for on a Linux. So we want to configure Windows file system. So after configure, we want to check the version, SNOT, open the command prompt as an administrator. Why? Because running SNOT, we need an admin privilege. So open the command prompt and run this SNOT-W. So check the network adapter. So here's the some direct some pre-requirements we want to install in Windows, especially the NCAP. NCAP is not mean the stuff, it's a network mapper. So for packet capture driver, we need to install the NCAPper. So installing SNOT on Linux. Well, installing SNOT on Linux, it's not a big deal. It's very, very easy stuff. First, we want to update and upgrade the system, and we want to install the dependency. The main dependency for SNOT on Linux is an nmap. So it's already predefinedly it's installed in Linux. So we not need to install it. Next, we using apt library, we install SNOT. So after installing SNOT, during installation process, it's ask you a IP address, local system IP address for networking. So after we want to configure the file, we need to enable the local rules. Oh, SNOT runs on the rules. There's two types of rules in SNOT. One is a local rule, another one is predefined rule. SNOT itself, there's a lot of around 125 predefined rules are exist in there. So rather than we creating our own custom rules to detect the traffic, so we want to enable the local rules path. So after that, we need to verify it's installed or not using snort-v for checking the version. So followed by the running command is a sudo for giving up admin privilege for running this command. Snort-I, it's a network card. So we specify our network card. So based on your system, it will differ. For my system, it's a ETH0, our network card. And also I'm calling the snort configure file, which I'm configure all the core elements. So also, rather than displaying the logs on console, I'm storing the logs on the file. So I define the path where logs not. It's an area where all logs will store. So followed by snort action. There's a top 3 actions in a snort. One is an alert, another one is drop and redirection. In Linux, the 3 actions are predefinedly it's there, but not in Windows. Windows is basically built for a convenience, not for a security purpose. So in Windows, there's only one action. It's an alert action, and I created a 2 custom script for dropping and redirection. So furtherly, I will explain about it. Before that, we see what's alert and what's drop and what's redirection. So assume there's an organization and there's a security and you are the team leader. So you just inform to that security. If anyone comes into our organization, you just come and alert me. There's a person came into our organization at this specific time using specific gate. So you just inform to a security. Security will if anyone comes into your organization, the security come and alerts to you. So it alert it's work like this. So it's at a minute it came on around 200 alerts. We can't able to manage those large number. So also we can't able to maintain those stuffs. So there's some unwanted stuff when the we can't able to say like that. So next step is on a dropping. We give some privileges to security. Hey man, see, don't give every allot to me. So if there are unwanted activities like any animals enter to our organization, you just block them. If anyone enter into our organization without our ID card, you just block them on a gate. So we just inform like the security. Security will block those peoples without the peoples without came ID card into our organization, the security will block those peoples. So it's a dropping session. So then we jump into redirection. Redirection is one of the most interesting area. So we inform to the security. So if the guy wears an ID card, so it's some suspicious, you redirected those guy to another block. So we will monitor its activity. If it's legit, we give an access. So it's a general. So now we jump in our technical stuff. So the system one is our organization. There's an attacker. When attacker try to ping us, so already Sir says the pinging itself also considered as an attack. So we just give generating alerts. So it's not generating alerts when someone ping our system. It's an alert session. Next drop. So when attackers scans using a nmap or zenmap tools, it's a suspicious activity, right? Before the attacker get connect with our system, we just block those attacker outside of the network. So attacker not able to connect with our system. So another one is redirection. So in our system, we are not hosting a HTTP service, we just hosting the FTP service. When the user try to connect with the HTTP service, the legit user not connect with the HTTP service, it just connect with an FTP service. So we instead of saying no to him, we just redirecting him his traffic to another system. In system 2, it's an HTTP service is running. So the attacker use the HTTP service. At system 1, we can able to monitor his behavior. So it's a legit now we give an access to him, or we just say to him, we are not hosting the web service. It's an attacker, we just drop him. So test environment. For this testing environment, we need a switch connecting those all systems. One is the attacker, its IP address is 192.168.56.0.1. The system one, our organization IP address is 192.168.56.1.1. The system two, it's our another system. We are redirecting those traffic to another system, right? The system IP address is 56.1.3. So all those systems want to be in a single network. So we connected those in a switch. So writing a custom rules. So writing a custom rules. So you can able to see the basic rule syntax. The action means defining the alert. We are generating our alert or logs or drop the packet or redirect those traffic. It's an action. First we mentioned the action. Next the protocol. Which protocol attacker used to communicate with us? That may be a TCP or UDP protocol, TCP IP protocol, even it's an ICMP packet protocol. So next, source IP address. Source IP address is our own organization IP address. So we can able to predefine it. Next, the source port. So we can't able to predict attacker come from which port. So there's an around 65,000, more than 65,000 ports on the internet. So we can't able to predict that, right? So I just given any. So the attacker come from any port. So next is a destination. Destination, it's an attacker's IP address. So attackers from which address? So also the destination ports, it's an attacker's port. Which port attacker used to connect with us? Next, the options. So we can able to see the example. I create an alert action. If any alert comes, it just shows the alert. So I use a protocol, I use a ICMP protocol. So if attacker try to communicate with us using ICMP protocol, you want to give an alert to me. Next, the source IP address, it's our IP address. For that, I not mention anything. I just given any from any IP address it came from any port. So also I not mention the destination IP. We can't able to predict the attacker's IP, right? So for that also I given any. So we also can't able to predict the ports. So I given any. So for message, we want to show the message, right? For ICMP ping detected. So next we want to given us unique rule ID for every rule. We can't able to create a one specific rule for every signature, every attacks. So we are going to create a more than lakhs of rules. So for that identification, we need a unique rule ID. So this is for switch. So rather than creating the rules on manually, we can able to create the rules using a GUI version. It's a snortpy.i. Using this website, we can able to create the rules in GUI version. So snort alert. So now we directly jump into the live demo session. So what's the scenario? If someone pings me, I want a snort to detect alert. So if attackers ping me, ping the system one, on top of system one is running a snort. Snort will generate the alert. Somebody trying to ping us. So also we can see the setup attacker. I am running the attacker on virtual machine. So system one is on a Windows, and I'm going to use a snort rules. So I think my VM is visible.
So please, please stop this sharing and start sharing your VMware. Okay, it's not visual.
Oh, 1 minute. Sir.
Yeah. Now it's okay.
Ah, this is our attacker system. I just logged in, and we can able to see the attacker's IP address is on a. Uh, Yeah, it's there 102. So we open our victim. This is Windows. So before starting the snort, we just check it's installed or not. For that snort -v version, so it's installed the version 2.9.20. So now we're going to run it. Before that, we need which adapter is our system is connected. So for that, using snort-w to check our network adapter. Our network adapter is 4, is our IP address 192.168.1.1. So we run the snort. So this is the command. I'm already opened the terminal on a admin privilege. So I don't need to give the administrator access. So snort -e-i for specifying the interface code. It's on a 4, and C, I'm specifying the config file. So this is the config file which I am previously discussed about it. So you need to config this, especially the file location. Also, we enabled the local rules. Yeah, we included the local rule path. So we want to enable it. Defaultly, it's a disable. We want to enable it. So we're running this snort. It takes some time. Parallelly, we tried to ping from the attacker system. So this is the attacker system. I know the victim's IP address is 192.168.56.1. So I am trying to ping from here. 1.1. So ping has been established. So we go and check at our victim system, it's showing alerts or not. So I just already mentioned all log files want to store in a log file. So I am going to open it. So this is the log file. You can able to see the alerts, the time, the date and time, and the deducted ICMP ping or ping come under the ICMP protocol, and the source IP address and destination IP address. So here you can able to see the source IP address and destination IP address. So this is the alert system. Now we are going to perform the drop. So for this, I wrote on a custom script for drop. So I just run the script. So now you can able to see that our script is blocking the IP request which came from 192.168.1.0. This IP address is an attacker's IP address. We are blocking those requests. So yeah, now is a redirection path. In redirection path, there's totally 3 systems. One's an attacker, another one is system 2, system 1 our own organization, system 2 is another organization. It's a clone. Now when the attacker sends the request, our system 1 acts like a middleman, transfer those packets to system 2. Then system 2 handle those traffics. System 2 sends the acknowledgement to system 1. Then system 1 act like a middleman and transfer to the attacker. So attacker always communicate with system 2. We can attacker's behavior. So for this, so this is the system 2. So in system 2, I run a HTTP service. But in original, in system 1, I run only the FTP service. When attacker tried to connect with HTTP service, I just act like a middleman and transfer those packets to system 2. Then system 2 will send the acknowledgement to system 1, followed by system 1 act like a middleman and transfer those packets to attacker. Okay. Before that, we will need to run the redirection script. So redirection script from attacker side, I'm trying to access the HTTP service. For that, I'm using a curl command. Curl followed by a system 1's IP address 192.168.56.1.1. So now we can able to see the web service. It shows like a title, secure login port, and we are getting the input from a user. This is the port. This is the web service. But actually, in system 1, there's no web service inactive. For cross check it, we open our browser. Yeah, now we enter the system's 1 IP address. It's 1.1, right? Oh. So it's redirecting those all traffic to that another system is responding to it. When we turn off our script, after we try to log in, so here you can see the new connection from 192.168.1.0. This is our attacker IP address. Now we also can able to see this from system 2. Oh, it's not showing from system 2. So now we stop this script. So now we try to connect the same IP address. Now it shows we can't able to reach there. So why? Because in 192.168.56.1.1, we are not running the HTTP service. We in system 2 only we are running the HTTP service. We redirecting through those packets to system 2. So only system 2 send the acknowledgement to attacker. So this is the demo. The further session continued by our sir.
Hello.
Yes,
Am I
sir.
audible?
Yes,
Yes.
yes, sir.
Yeah. So let's see. I will just share the screen again. I hope my screen is visible. Okay.
Sir,
Is it
visible.
visible? Okay. So my student, he demonstrated how to install the Snort on Windows. Okay. Basically, this Snort is not designed for Windows. Okay. You can try these options, and you can configure using these commands. Okay. So you can run the Snort on Windows. And then he discussed about the how to configure the Snort on Linux. That is pretty easy. Okay. If you go through the documentation of Snort, it is already there. Then he discussed about the different snort actions. Okay, so the three most prominent action the snort performs are the alert. So whenever the attack attempt happens, when the traffic is not as per the access control policy or as per the rule, then it will alert the security administrator. Okay, that is what. But the problem is that it will generate the massive amount of alerts for the packets. For every packet, it will give the alert. So that is just like a you can say that it's a millions of alerts will be generated. So the security administrator cannot take care of those alerts because he cannot read all those alerts. He cannot go through all those alerts. So what he will do, while the security administrator, he or she will delegate some power to the snort and say that, why don't you take some actions? Okay, so I don't want alert. You give me the alert, but you only take some action. So if you see some malicious packet is coming, which is not as per the rule, then which is not as per the access control policy, why don't you drop it? So okay, you just drop the packet, don't forward the packet to the destination, and log that packet, store that packet, so those packets can be investigated deeper in future for threat intelligence or proactive forensic. Another point is, what if some attack attempt is happening onto the our system? So snort will detect that attack attempt, but the snort will don't drop the packets. What the snort will do, it will redirect that attack traffic to another machine. That may be a honeypot, that may be a honeypot or any machine which is running the deceptive services. So so the traffic is not redirected to the original machine, which is the traffic, okay, original destination. It will be redirected to a dummy machine, maybe the honeypot, and that honeypot will respond to the attacker. So attacker, we are not denying access to the attacker. Attacker is pretty happy in accessing the fake services installed onto the honeypot, and in that way, we can monitor the behavior of the attacker and we can gather some threat intelligence about the attack, and that intelligence can be shared with the other companies or other organizations. Okay, that is a redirect. So he successfully demonstrated all the modes. So through the test environment, okay, and again he spoke about the what is the basic syntax of the snort rules. So the first, it is action. What is the action you wanted to perform, whether alert, drop, or redirect? For which protocol you wanted to apply this rule? What is attacker's IP? What is the attacker's source port? What is the destination IP? What is the destination port? For which these are two. The last two are for the machines which are in our network. The first two, source IP and source port, are for the attacker machine, and the option, some sort of option. So if you see the example here, alert message is created for the ICMP. If the ICMP packets come from any computer, any computer having any IP address, any port, to any destination machine having any port open, so on the port, then it will give the alert. And it will have the every, you have to make sure that every rule should have the unique ID. Unique ID you should have, okay? So that he discussed. And there is a website, okay, so called as snorpy.io, okay? So you can go through this website and you can create some attack signatures, okay? You can create some rules for the snort for a particular attack, okay? That you can do, and you can plug those rules into the snort and you can test them, okay? Then he has successfully demonstrated the three types of demos. One is for the alert, okay? So upon watching the malicious packets, the snort will give the alert to the security administrator. Next one, not only it will give the alert, it will drop the packets, okay? So because some more powers are delegated given to the snort. So if you see some malicious packets, kindly drop those packets and store those packets for future reference. And next, if you see that attack is happening, okay, so don't deny, don't stop the attacker. Kindly redirect it to some honeypot node or some honeynet, and make him engage and learn from his or her activities, and that knowledge can be used for the threat intelligence, okay? So okay, so he has demonstrated three types of actions of the snort. So there are some more applications of this snort are there. So of course we can use it for enterprise network monitoring. So what is happening in our network security point of view, that we can watch, we can use the snort for that. We can use the snort for the security research also, okay? So to find out the new types of attack, we can create the rules, we can see, and we can of course improvise the existing rules of the snort. It can be used for academia educational environment, as the commercial ideas are very costly. So if you wanted to deploy for the intrusion detection system for the academia educational environment, So IDS can be SNOT can be used, it can be customized, and it can be deployed with okay. So with so there, of course, there will be no cost with that, and it can be used for the threat detection and critical infrastructure also. So just like industrial control system or cyber physical system, the SNOT can be tailored, or it can be made a lightweight to do some sort of traffic monitoring and threat detection. There are some limitations of IDS are out there. Okay, so basically, for high speed network where the latency is a concern, okay, for example, if I will say the communication is supposed to happen within a millisecond or microsecond or nanosecond, this IDS, what it does the packet inspection. So, and it holds the packet, it does the packet inspection, it checks every packet against the rules, and it takes some time. If a particular service is a time sensitive, okay, then definitely it will degrade the performance, it will create the performance issues. Okay, again, the ideas built-in rules are not so good, not so effective. If you won't create the rule properly, it will generate a lot of false positive and false negative. Of course, false negatives are very dangerous. If you classify the packet as a normal packet or benign packet, but actually the packet is a malicious packet, it will have the catastrophic impact on your network, and the security breach may happen. So fine tuning of the rule is required, and maintenance. Okay, and as IDS is again the software based solution, it's not a hardware based IDS, it's software based. So there are inherent bugs and vulnerabilities are there in the IDS itself. So sometimes attacker may attack the intrusion detection system itself. Okay, and it will compromise, they may change the rules according to their will, and then whatever they do, it will happen as per their wish. Okay, so and the SNOT works on the signature based detection. Basically the rules what we are creating, those are purely signature based, it's not anomaly based. So definitely SNOT will not be good for the zero-day attacks, so you cannot deal with the zero-day attacks using a SNOT. It may work for the attacks which already happened. Okay, for the well-known attack it may work, provided the rule or the signature what you have created, it is proper. Okay, so that's it from from our side about the ideas. Okay, SNOT. So is there any question about the SNOT? Hello.
Yes, sir, if you have any question, please ask.
Okay, there are no questions in chat box also. Chat box also.
Sir, one question is there in chat box that, sir, why is the signature based is not applicable to the modern IDS?
Modern
Mr. Bala,
IDS.
yes, Mr. Bala asked. Okay. Modern means it may be generative AI or some kind of things they want.
Modern IDS. No, no, that's question. Okay. Modern IDS means what?
Yes, Mr.
Just see
Bala,
the
please ask your
just
question.
see, modern IDS works for. Just see, when you say modern IDS, that I don't know what do you mean by modern IDS. We can say that current IDS intrusion detection system, they work not only on signatures, they work on anomaly based. So basically, the current IDS systems are the hybrid IDS. They not only take help of the signatures or the rules, they do some anomaly detection also, so that both the well-known attacks and the zero-day attacks can be taken care of. Okay, the next question is how to download it in Mac OS. That need to be investigated. We don't know about that. We tried it for the Linux, we tried it for the Windows. Mac OS, you may try, and there may be some blog are there. You can see that. You can do that.
Okay, sir, one question from my side. You
Yes.
talk about IDS history, okay, history about IDS. And at
Yes.
the end, 2025, you talk generative AI based IDS.
Yes. Yes.
Okay,
Yes. Yes.
okay. Please give some insight so that a student can start some project or some research work on that. Okay, what kind of things from your side?
You see, the point is nowadays the large language models are heavily being used to generate the malwares. Okay, so If you see the some GPTs are there, fraud GPT, this GPT, that GPT, some dark GPTs are there. Okay, so attackers basically what they are doing, they are not developing everything from the scratch, even the malware also. So what they are doing, they are telling the GPTs, if the large language models, to create the, maybe their proprietary large language model or the GPT. They are asking them to create the malwares, and they are those are heavily being used to attack the organizations. Now the point is like that, as the attackers are proficiently using the generative AI, at the same time the generative AI can be used for the defense purpose also. So sometimes what you can do, if you see some malware, some sort of new malware, and or something you can see that can be given to the generative AI maybe, and you can ask it to create a signature out of it. Okay, because if you are going to create a signature manually, you have to study the entire code. Okay, that will be very time consuming, and by the time you come up with the signature and you plug it to your ideas, it is too late. Maybe that attack is happened so many places, so you are too late in responding. So in that way, you can use you can give that to the generative AI, and you can ask them, you can train your generative AI to create the signature, so that you can test on the old malware samples, uh, and generate some training can be done, and then testing can be done on the new type of malware samples to create the signatures. Some sort of thing can be done. Okay.
Okay, sir. Thank you, sir. If no question, then we will meet tomorrow at 10.
Okay.
Satya
Okay.
sir in meeting, that's why he told that.
No problem. So,
Okay,
okay,
sir.
so tomorrow we are going to talk about the cyber deception, as we concluded that redirection. So the last part of SNOT action is a redirection. So instead of denying the access to the attacker, we simply redirect attacker to the honeypot or some deceptive environment, and we will observe his or her action, so that based on that we can generate some threat intelligence. Okay, so the tomorrow's session is all about the cyber deception. It will be purely theoretical. There may not be a demos. Okay. Okay, this is for your kind information. That's it from my side.